Welcome to this LangChain RAG tutorial. My name is Raman and I'll take you through the steps from how to set up a basic chat with AI all the way to having your own RAG chatbot up and running. You can see the scope of this tutorial currently on screen. We're going to be going through each of these steps with the assumption that you've never used LangChain before. All the files that we're going to be going through will be accessible in a public GitHub repo, which is linked down in the description. Before we get started, you're going to have Python set up with Visual Studio Code to follow along. Now, if you haven't done this yet, I'm going to leave a link down in the description to a video showing you exactly how to do that. Another thing that I would recommend, if you aren't familiar with the concept of RAG or Retrieval Augmented Generation, I've done an in-depth video going into exactly what it is, how it works, and what it's used for, with real-world examples. That's also down in the description. Go check that out if you aren't familiar with RAG. To run any of the files in this tutorial, you're going to have to install the requirements. And all that is just a list of libraries that we're going to be using in each of these files. And you can do that by opening up a terminal and running pip3 install-r requirements.txt. Just make sure that when you open up the terminal, you're actually in the project folder. And you can follow all the instructions here in the README file. That'll get you set up. Lastly, we're going to have to set up an OpenAI API key. And that's so that you can access the actual models like ChatGPT, 4o, 4o Mini, and so forth. So how you do that is by going to platform.openai.com API keys. Now, if you haven't set up an account with them yet, you can go ahead and do so. Once you have, you can open this up. I would strongly recommend loading some credits on. $5 will be more than enough to do what you need to do. Once you've done that, hit this create new secret key. I'm going to call this test. Hit create secret key and then copy this. Click done. You're going to have a .env example file right here. So what you want to do is rename it to .env like that. And we're going to store all of our API keys here for this project. So I already have a .env file here. So I'm going to plug this key in right here. Once you've done that, you should be up and running to follow along with the rest of the tutorial. Now, without further ado, let's jump into part 1, basic chat. All right. Let's take a look at part 1 of this tutorial, where we're going to learn how to create a basic chat with AI using LangChain. So let's take a look at what's happening in this code, this 01 basic chat. So let's start at the top. So the first thing we're doing is we're running this load.env function. And all this is going to do is it's going to go to our .env file and it's going to pull in all the variables that we've set up here. In this case, we just have OpenAI API key. And I'll show you why that's relevant here in a moment. So after this happens, the next part of this execution is actually at the bottom right here. This if name is main, then run the main function. So what is this actually doing? So in simple terms, all this is doing is if I run this file directly, say with this button here, this is just going to say that I'm actually running this file directly. If I import it from somewhere else, it's not going to run this. But if I'm running just straight up this file, it's going to execute this main function. So what happens when it executes this main function? It's going to go right in here and it's going to create an LLM for us with this initialize LLM function. And by the way, all an LLM is just a type of AI that's been trained to understand and generate human-like text. And it's called large in large language model because it's been trained on a ton of text data. So when we go into this initialize LLM step, all we're going to do is run this chat OpenAI function and we're going to give it the type of model that we want to use. In this case, GPT-4o Mini. And just to jump back to the .env file, just so you're aware of the relevance of this OpenAI API key, there is actually a parameter that you can specify right here saying OpenAI API key equals and then whatever your key is. Now, we don't actually need to do that because by running this .env function, we're pulling in this value to make it available for this code. So once this happens and we return this chat OpenAI, it then in this LLM goes into this chat loop function. And all this is doing is it's creating a loop and it's asking us for some input. Once we provide our input, if we've said exit, it's going to break the loop, meaning it's going to stop this whole thing and the program's going to end. But if we don't say exit and we type in some kind of question, well, anything other than exit really, what it's going to do is it's going to run this invoke function on LLM. And this is basically a function in LangChain to run some kind of chain. And a chain in LangChain is basically a sequence of operations. Like if we want to ask the model something and then have another step that analyzes that data and then have another step that formats it, that can all be created in a chain. And when you say whatever the chain name .invoke, all it does is it runs that chain. So in this case, our chain is pretty simple. We're just going to take the query from the user, and we're going to pass it to the large language model, in this case GPT-4o Mini, and we're going to return the response. By the way, the reason we're saying result.content is because OpenAI actually gives us a ton more information than just the actual text response. So let's see this in action. I'm going to hit this button right here to run it. Let me move myself up here, and we're going to say hello, and there it responds to us. Hello, how can I assist you today? Let's say something like, what is the capital of Italy, for example? The capital of Italy is Rome. Right, so if I say exit, it's going to kill the whole thing. So just to show you, I am going to, I'm going to remove this content right here to show you exactly what we get back. If I run this now, let's say hello. So what you'll see here is we get a bunch of more data. You move myself down here. Here's the content, which is the actual LLM response. Then we get a bunch of things here like the tokens and so forth. The model name. Basically, if you're building some kind of application, this can be very useful data to track things like how much usage have you already used and so forth. So let's hit exit. Let's change this back. Now I'm going to run this again, and I'd like to show you something else here. So if I say my name is Raman, it says, nice to meet you, Raman. How can I assist you today? And I ask it, what is my name? I'm so sorry, but I don't have access to personal information. So as you can see, there's a bit of a problem here because it doesn't track the history of the conversation. So it's not context aware, meaning whatever I tell it in the next question that I ask, it's not going to know what I asked previously, which leads us actually into the second part of this tutorial where we're going to learn how to add history to the chat. All right, so let's jump into the second part of this tutorial where we're going to learn how to add history to our chats for better responses. So everything in this second file is essentially the same as in the first part, except we've got these two objects that we're importing now, human message and AI message. What we're going to do with these is we're going to use these to store the messages in the conversation. So human message will be obviously what we tell the AI, and AI message will be what the AI responds to us. So if we jump back down here again, this will always be for the purposes of how we're running this code right now. This is how it executes. So it goes into this main function. We're initializing the LLM. Then we're going into chat loop. So right here is where the difference is. We've got this chat history array. Now, when we enter this loop, we're going to give our input. Then what we're going to do is we're going to create this messages object, which is going to store our chat history, and it's going to add our query to that. It's going to create this human message with content being whatever our input was. Then we're going to give those messages to the LLM to generate a response for us. It's then going to print out the response and store our initial message and the AI's response in chat history. Then when we ask it another question, it's now going to ask the LLM our question together with the chat history. So what does this actually look like? Let me run this, move myself up here again. I'm going to say my name is Raman. It says nice to meet you. Now, if you recall, in the previous part when we asked it what is my name, it wasn't able to answer. So let's see what this one does. What is my name? There we go. It says your name is Raman. How can I help you today? I can also ask it, what was the last question that I asked you? There it says the last question you asked me was, what is my name? Which is exactly correct. So I want to actually show you what this looks like. If I uncomment this, and let's try this again. I'm going to run this. I'm going to say, my name is Raman. Now, as you can see here, we're printing out what messages actually contains. It says messages to be sent to the large language model. And it's saying human message, content, my name is Raman. Now let's say, what is my name? Now, as you can see here, remember, it's giving this messages to llm.invoke. And it's saying human message, my name is Raman, that was the first message. AI message, that was the AI's response to my message. Then another human message, what is my name? And the AI is saying, your name is Raman. How can I help you today? Now, if I say, what was the last question I asked you, you'll see it just keeps adding to this object. Now we have here, your name is Raman, how can I help you today? What was the last question I asked you? Now it's appended that to the array. And there's the AI response. So this object kind of keeps adding and adding so that the AI is context aware of what the whole conversation is about. So that's pretty much it for the second part of this tutorial. Now let's jump into the next part, which is document splitting. All right, so why document splitting? If you're asking that question right now, now's the perfect time to go and watch that video in the description about what is RAG actually, like what is it used for. So I'm going to touch on it briefly, but I strongly recommend you watch that video if you're not familiar with the whole concept. So basically, each LLM has a certain input context window. So what does that mean? It means that if you want to ask a question about a very long book, you can't say, what did character X do in this chapter, and then just cram the whole book in there. The LLM is going to reject that and tell you that, hey, you've exceeded my input length, like my maximum input length. So how do we get around that? So we get around that, and this is the whole concept of RAG, right? You take your book and you break it up into chunks. You can split it up by chapter, by paragraph, by sentence, whatever. There's plenty of options. Then what you're going to do is you're going to write your prompt and you're going to say, what did character X do in this paragraph or in this chapter? And what's going to happen behind the scenes is it's going to take your question and it's going to say, answer the user's question to the best of your abilities. Here's the question. And then using this context, and it's going to take chunks of that book, either chapters, paragraphs, whatever, the most relevant ones, and we'll get into how that happens later. And it's going to put that into the prompt, and it's going to give the prompt to the LLM, and the LLM is going to return a response. So the reason we split documents is so that we can create those chunks. So let's see how we do that. So once again, everything here is the same as the previous two parts. We're going to start here in this main function, and what we're going to do is we're going to load the specific document that we're going to work with. And how we're doing that is up here. We're getting the current directory, which is the path of the project. Then we're going to get the document path, and right now it's in this documents folder, and the file that we're going to be using is the book Moby Dick. So this is the entire book, and what we're going to be doing is we're going to be splitting this book into chunks. So if I go back to document splitting, the first thing we're doing is we're loading the document, and by the way, this can take in multiple documents in this directory. So it's going to say we've loaded so many documents. Right now we're just going to be loading Moby Dick. Then we're going to split the documents using this function, and it's going to use a text splitter, and we're going to be using the specific type of text splitter called the recursive character text splitter. And what this does is it tries to split the text at logical points, like at the end of a paragraph or at the end of a sentence. If that's still too long based on the chunk size that we give it, and this is just the amount of characters that we're going to be splitting it by. So if that sentence is longer than 1,000 characters, it's going to split it at the 1,000 character point. But let's say the sentence ends at character 900, it's going to split it there. And all the chunk overlap is for is to just make sure that we don't lose context between chunks. If we have one chunk go to character 1000, right, and it cuts off in the middle of a paragraph and the next chunk begins at the beginning of that, there's going to be very little context as to how these two chunks actually connect to each other. So that's why we have the chunk overlap. So then we're actually going to split these chunks right here and return them. And I'll show you what this looks like. We're basically going to return the first two chunks right here. When I run this, if we scroll up, here it is. I loaded one document, split the document into 1,808 chunks. This is a pretty big book. So here's the first chunk, and you'll see that's going to be this first part of the book, right? And if we scroll down, it's going to go up to here. And then the second chunk is going to start right here and finish over there. So that's basically text splitting. So the next thing we're going to get into is actually vector embeddings, which is just numerical representation of text. So let's jump into that. All right, so let's take a look at this part 4, embeddings. So firstly, what is a vector embedding? A vector embedding is essentially just numerical representation of text. And all that allows computers to do is just to work with text using its actual meaning, as opposed to like looking for similar words whenever you're doing specific kinds of searches. So let's see what this looks like. We have everything exactly the same as the previous part. So we're going to be loading the document. We're going to be splitting it into chunks. And here's where the difference comes in. We've got this create embeddings function, which is going to use OpenAI embeddings, this specific embedding model. And there's different models of how to create these numerical representations of text. And each has its own advantages and disadvantages. But that's outside of the scope of this video. So we're just going to be using the basic model here. And we're going to be creating embeddings for a specific chunk of text, which is just going to be the first part of this book. So let's run this and see what this looks like. So if I scroll up past all of this here, let me drag this up a little. So we've split this book once again into 1,808 chunks. And here's the first part of the book, right? And this is the embedding for it. This is just what it looks like in the background. Now, you don't have to worry about any of this. This all happens in the background. You don't have to do anything fancy with this. We'll get into how we use that in a moment. So now that that's out of the way, let's take a look at the next part, which is basically creating a vector store and using basic retrieval on it. Alright, so let's take a look at part 5 of this tutorial, which is creating basic vector store and retrieval. So now that we've created our numerical representation of text, all those numbers from the previous part, what do we actually do with this? Well, for our RAG system to function, we need a place to store all of these values so that we can search this database whenever we need to answer users' questions. So let's see how we do that. So we're going to be using Chroma, and Chroma is something called a vector database. And all that is just a database that stores vectors, these numerical representations of text, as opposed to raw text. So let's jump down here. So we're going to be doing all the same kind of stuff. We're going to be loading the document. We're going to be splitting it, creating embeddings for that document. Then we're going to be creating the vector store. And if we jump back in here, all we're going to do is we're going to create a DB folder in this directory. If I come up here, we're just getting the current directory, and we're saying the DB directory, which is the directory for our Chroma database, it's going to be the project directory in the folder DB. So it's going to create one if it doesn't exist. So if we go back down here, so it's going to create the Chroma vector store using the chunks and the embeddings in this directory. If that database already exists, it's just going to load the existing one. It's not going to create a new one, because whenever you run this to create vector embeddings, it does actually cost a little bit of money. So you only want to run this if you need to update your database or if you're creating a new one. So if we go back down here, so we create our vector store, then we ask a sample question. What is the first line of Moby Dick? Now what happens here? So we have this perform retrieval function. If I jump over here, we're giving it the vector store, and we're giving it the query and this parameter called k. And what it's going to do is run something called a similarity search in the database for that question. So if you recall the question here is, what is the first line of Moby Dick? So what we're going to do is transform that question to a vector embedding. And this all happens under the hood in LangChain. So not something you have to worry about, but just so that you understand what's happening. We're going to transform that to a vector embedding, and we're going to take that and run similarity search against the vector database. And all that does is it finds the chunks that are closest in meaning or content to the question. So it might have references to first line of Moby Dick or anything that's similar in nature to our question, or similar in content, I mean. So what this is going to do is going to find those similar chunks. It's going to return the top 3. This is what the K is for. Going to return the top 3 chunks that are closest to what we've asked. And it's literally just going to run that here and return the results. So let's see what this looks like when I run this. So it should create, there we go. We have a DB directory. It's creating the vector store right now. Let me move myself up here a little. Okay, there we go. So let's see what happened here. We created the Chroma vector store. We have the query and we have the retrieved chunks. So these are the top 3 chunks that are relevant to this question based on the similarity search. Now keep in mind, this isn't perfect. So there are different types of searches for different situations. In this tutorial, we're using similarity search. But you can always go to the LangChain documentation and see what they have available. So let's see. It's returned this chunk, then it's returned this chunk, and this chunk up to here. So these are the top 3 based on the question that we've asked. So this is the retrieval part of the RAG system. So now that we know how that works, let's jump into the next part, which is going to demonstrate the QA chain. Alright, so let's take a look at part 6, which is our QA chain, which just stands for question and answer chain. And if you recall, all a chain is in LangChain is just a sequence of steps or executions that produce some kind of output. So let's scroll down here. So what are we doing? So this is kind of like a standalone example from what we previously did. All we're doing is we're creating, well, we're initializing the large language model first, then we're creating a QA chain. If I jump in here, we're creating something called a system prompt. And that system prompt, by the way, system prompt just sets kind of like the overall context for a large language model. Like, hey, you're an assistant, or you work for this company and you should know this, all that kind of stuff. So all we're telling it is that it's an assistant for question answering tasks, and we've got some context, and it should answer the questions from the user using this context. And if it doesn't know the answer, just say it doesn't know. So the next thing that we do is we create this chat prompt template. And all that is just a structured way of providing input to the large language model. As you can see, we're giving it a system prompt, which is the overall context. Then we're giving it the chat history right here, which is whatever conversation we had with it before, so it's context aware. And then we're giving it the actual input, the question that the user asked. Then we're creating this create stuff documents chain using the LLM and this QA prompt, which is the prompt template. And all the create stuff documents chain is just a sequence of operations that allows us to get context from documents, like the document chunks, and use that in a prompt to actually get data out of it. Perhaps there's more that it can do, but that's what I'm aware of at this point anyway. And that's what we're using it for. So once that is done, once we've created this QA chain, we're going to create a mock document chunk using this document function. Its content is Moby Dick is a novel by Herman Melville. And then we're going to ask the question, who wrote Moby Dick? And all we're going to do is we're going to use this QA chain, which is this one that we've created up here. And we're going to give it the input, which is the question, who wrote Moby Dick? We're going to give it the context, which is the document. And now you can have multiple documents. Like you can provide 3, 4, 5 chunks. In this example, we're just providing one. And then we're giving it the chat history. In this case, we don't have any chat history, but we could. And we'll jump into that in the next step where we're going to tie all these components together. And then we're just printing out the question and the answer. So let's see what this looks like. If I run it, there it says question, who wrote Moby Dick, which is what we asked here. And then the answer, this result of this QA chain, is the LLM's answer. Moby Dick was written by Herman Melville, which is exactly what it says here in the document that we provided it. So now that you're familiar with the various parts of what a RAG system comprises, or the various parts that make up a RAG system, let's actually jump into the final version of the chatbot and see how does this whole thing work. So what does this history-aware retriever chain actually do? So imagine you were asking a question like, who wrote Moby Dick? And you get a response saying, Herman Melville wrote the book. And then you have a question like, what was his idea of the book, right? Now, if you recall how the system works is we take the user's question, we convert it to a vector embedding, and then we do similarity search against the vector database, meaning we take the question and we try to find chunks in the database that are relevant with their content or meaning to the question. Now, the question, what was his idea of the book? It doesn't contain any context of who we're talking about and what book we're talking about. So that presents a problem because the response you're going to get is, I don't know. So that's why we have this history-aware retriever chain. And all it does is, it says, it's an LLM step basically. It says, given a chat history and the latest user question, which might reference the context in the chat history, formulate a standalone question which can be understood without the chat history. So basically, we're reforming the question. If we say, what was his idea of the book? We might reform it to something like, what was Herman Melville's idea of the book Moby Dick? Now that contains a lot more context to do similarity search on. That way, when we search the database, we're going to find relevant chunks. So that's basically what this piece does. Now if we scroll back down here, the next thing we're going to be doing is creating this QA chain, which is exactly what we did in part 6. We're just creating a structured prompt for the LLM to answer a question. Then we're going to create another chain called a RAG chain. And all this does is we're going to be using the history-aware retriever first. And remember, a chain is just a sequence of operations. So we're going to run the history-aware retriever first. The user's going to ask a question. We're going to reformulate the question if it's necessary. And then we're going to use that as the input to the QA chain, which is going to actually take our document chunks and answer the question based on those document chunks. And that's basically it. And we're going to start the chat loop with that RAG chain. Now guys, if you've made it this far in the video, I hope that you found some kind of value out of this. I'd really appreciate it if you could drop a like. It really helps, and these videos take a lot of effort to make, so I'd really appreciate it. Anyway, let's look at an actual demo of this. So let's run this. Let's say something like, who is Moby Dick? Let me move myself up here. He's a great whale, and so forth. You can say, what is he doing in the book? Right, now you see here, there's no context to do similarity search. Like, who is he, what book? So if I run this, in theory, that history-aware retrieval chain should reformulate that question into something that's easier to do similarity search with. So let's run this and see what happens. So there we get a response. In Moby Dick, the whale Moby Dick is primarily depicted as a formidable, mysterious creature. All right, there we go. So that's basically RAG in a nutshell. So now I can ask it a question like, what is my name, right? It wouldn't have any context. I don't know your name. Now, let's say something like, who is Aladdin? I did not expect it to answer that actually. So let's try tweaking this. Let's change the system prompt to if the answer is not contained in the below context, just say you don't know. All right, let's save this. I'm going to restart that. Let's run this. Say, who is Aladdin? There we go. That's much better. All right, let's just make sure that it still works. Let's say, who is Moby Dick? Then we get a proper response. What is he doing in the book? There we go. Now there you have it, guys. There's your own RAG chatbot up and running. You can, I did not mean to do that, exit. There we go. Now you can basically load up any document you want or multiple documents as well if you want into the system. Play around with the settings, play around with the types of retrieval, the search, and you can basically build any type of RAG system that you'd like. All right, well, I hope you guys enjoyed that, and I'll see you in the next one.